My name is Hansung Kim, and I'm gonna introduce some interactive 3D audio reproduction using 360 cameras. So I'm gonna tell you how computer vision technique can contribute and support this kind of audio-based applications. So actually, to get the best way to reproduce the acoustic of the spaces should be definitely measuring room impulse response, but sometimes it is quite difficult according to the environment or some situations. It can be quite invasive. You have to bring everything in the space to measure, and the room impulse response is valid only for the point, the location where you just measured. So here we try to provide some a bit simple and practical method to estimate the room acoustics for reproduction of spatial audio, and also provide some metadata for the room environment, some spatial environment, using just off-the-shelf 360 cameras. So here we capture the scene and provide some approximate room 3D room geometry, and also acoustic room modeling as a metadata to provide the kind of metadata in this pipeline, whole S3A pipeline, in both production side and also reproduction side. So this is just an overview. So we capture the scene with very simple, very small 360 cameras, take 2 photos of the scene, and then we try to reconstruct 3D depth information from the scene, from 2D photos, to get them depth estimation from that. And then on the other hand, we also analyze the photos using deep learning pipeline to get some semantic object labels in the scene, so to understand what kind of objects are in the scene. And then by merging 2 information, we get full 3D, approximated full 3D geometry with object labels, and we assign some material mapping to that, to simulate them. And then that kind of full 3D scene can be simulated to get spatial audio rendering in real time, or to simulate some room impulse response in virtual environment, to get them approximated estimation of that. So this is very simple method. We use 2 cameras vertically aligned that, and then using some computer vision method like a feature matching, we can get that kind of depth information of the scene. So that is a sparse depth map using feature matching automatically produced. And on the other hand, we also use deep learning-based CNN architecture for semantic image segmentation to understand what kind of object in the scene. And we have this kind of material properties in the table, like a lookup table, and then we map the materials directly to each recognized object. Because in computer vision, material recognition is much more difficult than object recognition. So we just use a simple object recognition, like a table, chairs, and carpet, and ceiling, and then we map the materials to that. So here I can show some experiment. So we capture several scenes of different environment, like some normal living room type or large halls, and then different room type and different sizes. And then we actually estimate, measure the real room impulse response, and also simulated the room impulse response from the reconstructed geometry. And we compared some early decay time for early reflections and RT60 for late reverberation. And that graph shows the line shows the ground truth line, and then dotted one is J&D range, and then you can see that most of them are quite close to the ground truth, and then most of them are within the J&D. But in some cases, actually, they have some kind of large errors, like here. Here, what happened is actually there is a large mirror and a big window in the room. So actually, computer vision algorithm didn't really work well for that. So actually, they couldn't really detect the surface on that location. So that's why some early reflections are quite wrong. And here in rate reverberation, there is also quite big error here, because in this scene, it is a large hall, but actually there are quite many some panels on the wall to observe the sound. But actually, the camera couldn't really detect that kind of materials, and then just modeled it just as a concrete wall. That's why it gives more reverb in the scene. So that is kind of a limitation of computer vision technique, but still, it could provide quite good initial estimation of the room acoustics. So we implemented some demos in VR. So I showed some demo yesterday, and then some demo video is available on YouTube. So summary, we use the vision-based technique for 3D reconstruction and interactive spatial audio rendering. But still, we have some work for more better material detection, and also we are doing some subjective evaluation of plausibility in 3D audio reproduction.